I think everyone will agree we've got a great lineup of lectures today. There's something here for everybody, I think. And I'd like to take the opportunity to say thank you to Sarah and to David for putting together such a great collection of lectures for us.
This is given by Allan MacDonald, Head of Network Team Wireless Network Developments Limited. Right, okay, a few more letters. WND is an LPWAN network operator deploying IoT networks across Latin America as well as the UK. Allan manages the infrastructure and development activities for the UK arm and provides the same for the larger group. The UK is, well, in effect, the guinea pig for the larger market. Allan has been in this role since 2017, during which he's seen the UK grow from one Regus room to your own premises in Buckinghamshire. So, Allan, over to you.
I'll just check this today. This might be a lot briefer than we'd anticipated. I've been delegated to this role by our chairman, Chris Battayard, who can talk for Britain. I tend to be a bit more terse and to the point, and the accent might be slightly less penetrable. So if anybody's having difficulty understanding, please put your hand up and I'll rephrase. Moving on. So after that introduction there, I'm actually the operations director for the UK. I undertake, as said previously, all the development and infrastructure activities effectively for the group, and that covers the the physical network rollout of our infrastructure, as well as all the cloud infrastructure, billing, OSS support, and so on and so forth. So the initial tick of bandwidth, you can see there, this is a fairly familiar chart to anybody who's worked in the 3GPP spheres, or even as a consumer has had to use this technology. So back in the day it would have been 2G and Edge with GPRS at sub-kilobit rates, roughly analogous to BRI or equivalent. And then with the advent of 3GR99, HSDPA and HSUPA, we start to see a slower uptake within the consumer market on handheld and wireless technologies. Then, of course, there's an explosion of connectivity with the advent of smartphones and so on and so forth, which, of course, in turn drives the move towards 4G and LTE, and inevitably in the long-term future, the move towards 5G itself with plus 500 megabit rates in theory. In practice, it would be good to see. So that gives us our layman's curve, as it were, of long-term wireless evolution for bandwidth. The original proposition, M2M, which I'm sure a lot of you in this room have heard, machine to machine, it's a very simple way of just saying there's no human involved in this interaction. It's purely interoperability data moving between two instances. A good example would be a SCADA network, as an example. If a front-end processor is speaking to a field RTU, that relationship could potentially be considered to be M2M. So the initial implementations of this were done on quad-band GPRS. Now, as I'm sure you're aware, the modules for cellular in those bands, at their initial point of sale was quite a substantial cost associated with that. There's also the bulk factor. It's only in recent years that they've actually gotten down to the point where they can be cleanly and safely mounted on a DIN rail or a similar cabinet environment and left to run their course without causing all sorts of heating and power issues. Power, of course, being the biggest issue in any sort of radio-based technology. You're constantly consuming it. If you're keying up or receiving, if you're sending a message, you're consuming power. That in turn leads to heat, which leads to enclosure issues, and you're all familiar with that. The bigger problem now is not so much the fact that we've overcome these constraints, it's the fact that 2G will eventually be sunsetted. It's become, in 3GPP parlance, technically a legacy technology. That's not to say it'll disappear overnight, it'll still remain around for the next 5, 10, 15 years, however long the technology is required. But eventually it will hit that tipping point where the cost for implementing it just becomes unfeasible. So, as is the way with the interweb these days, M2M is renamed IoT. So IoT in layman's parlance is the Internet of Things, which is just a fancy way of saying the data moves between this machine and this machine. That's basically it. Everything will be addressable as an IP endpoint, or rather, that's a bit of a glossing over the details. Everything will eventually transport all this data into an IP backend or cloud infrastructure, wherein it will be analysed and aggregated and reviewed, monitored, managed, and so on and so forth. So there's a number of use cases there. At the top of the IoT triangle, which is looking quite washed out there, I might add, the high-end bandwidth devices. A perfect example would be your Tesla car. Any sort of high-end managed consumer device that has management as a service built into it. The Tesla is a good example. The fridge in your house, if it is in any way particularly smart, if it is camped onto Wi-Fi, then that's effectively a high bandwidth service. The Tesla itself uses 4G and in some cases 3G fallback for transport of instrumentation and telemetry data to the core. These are typically high power, high cost implementations, and the devices can be numbered in the millions. They're roughly matched to the consumer footprint. So if you think about the number of people that there are in the UK alone, you might argue that each individual will have a laptop, a phone, in days of yore, you might have had a pager. There'll be a number of given devices that you'll have on your person, but the number of devices will be roughly analogous to the population within a country. Not so with the fatter end of the triangle here, which is where we traditionally play as the low power wide area operators. So what you'll typically see there are sensors in a multitude of applications. There'll be agriculture, we see Medicare, there'll be plant and asset monitoring for warehouse applications, cold chain management is another one that's seeing particular uptake in the Latin American countries, which effectively just means if your Coca-Cola arrives in a warehouse, it's meant to be cold by the time it gets to the fridge where it's for resale, and it's meant to stay cold until the point of sale. So there's a number of methods and tool chains that are used to make that a reality. In a shift from the model that I mentioned previously, where typically you would have a laptop and a phone and you'd be numbered in the millions of devices, because we're talking about sensors, these can be anything. So you now scale up to billions of devices. So it becomes important at that point to begin to reduce your cost. Otherwise, this becomes something that's untenable to implement. So, as I mentioned previously there, the top of the triangle is addressed by your traditional cellular, which would be 3G, 4G, and in future days, 5G. any other existing connectivity solutions. Typically what we see in some cases are Ethernet enabled devices that are just dropped on net onto a customer premise. Again, the IoT mass market, as it's referred to, is filled by ourselves at the bottom there as a low power, wide area provider. So to recap on the rough overview I gave there of the thousands of applications, this isn't a terribly good slide. It's the very definition of death by slide, whereas it seems to be predominantly text. It's incredibly hard to read. I'll run through it, and if anybody has any questions, feel free to shout out. I've no problem with that at all. So, utilities, water metering, electricity, gas and fuel metering, smart building management, renewable energy production monitoring. We're seeing a large push towards campaign-driven metering services. So, for instance, electrical meters, water meters, gas meters. Nobody's interested in oddly enough, sending somebody out with a clipboard anymore to go and read a meter or knock on doors. It's no longer a cost-effective exercise, and no matter what your thoughts in automation, it becomes quite a frightening bottom line if you keep maintaining that. So there's been a big swell of interest for that we're seeing. Within industry, predictive maintenance, gas distribution network monitoring, boiler monitoring, critical goods management, structural health monitoring. Not to go too deep into the SCADA approach or the SCADA sphere, where we sit in LPWA is rather than being invaded in the critical components of ensuring that a valve remains open and alarms immediately if there's a service affecting event. The approach is rather to flood the plant, as it were, with sensors at every available location. So for instance, a vibration sensor on a piece of factory equipment might trigger an alarm to say, you've gone over the threshold for vibration on this given piece of plant. Somebody needs to address this physically now, or it's going to be a problem that will cost you a lot more money in future. You can also use that for temperature and humidity sensing. One such organisation that I'm aware of is deploying sensors in the wild in multi-dwelling units that get built in with the fabric of the building at build point. So there's no regressive fit or anything else along those lines. And they reside in there as a value add for the property. At which point, when the tenant moves in, they get a reduced insurance premium because there's zero risk of there being a service-affecting leak that will then impact other people within the building. All this data gets aggregated on a number of back ends and presented and sold for whatever purpose the supplier deems fit. Automotive and fleet management. There's a huge number of applications that we're seeing there now. Geo Location Tracking, onboard diagnostic, and stolen car and motorcycle recovery. One such firm that I can think of, not motorcycles, but push bikes. So everybody's aware of the Boris bikes. Those schemes aren't as effective in some of the less well-heeled areas of some countries. You might find that some of the plant you've invested a lot of time and money in ends up at the bottom of a river or a canal. To mitigate that to a certain degree, some firms have begun fitting tracking devices almost within the saddle upright for the cycle itself. So it becomes this unobtrusive solution. You're not even aware it's there, but you as the asset owner know where your asset is within a given area. So you can tell if something's disappeared, you can tell if it's gone off the radar, and you don't have to send anybody around to do asset tracking and management. Or you can reduce the headcount for doing that. Geolocation tracking, we're seeing that being used quite extensively in large container applications, and not so much automotive, but more in fixed but mobile assets. So for instance, wheelie bins, milk floats, shopping trolleys, things that you just wouldn't think about. Small things. We don't tend to think about them as having value as consumers, but if you're the one that owns all these assets and they're numbered in the thousands, then that pretty quickly becomes a dent in your bottom line if 20% of that is disappearing on a yearly basis. you're able, with implementing geolocation tracking on these assets, to see where they are at any given time. Now, not all of that creepage is going to be down to theft. A lot of it's just going to be down to mismanagement of assets. You might not know where half of these things are. And again, this goes back to the old model of having somebody walking around with a clipboard, checking things off and saying, asset A is in location ABC. Okay, move on to location B. You don't have to do that with this particular application. It's effectively done automatically for you. And if there is an issue, then again, you send somebody out to resolve. The retail application, everybody's familiar with Amazon, obviously, and their smart button service. That in and of itself typically is Wi-Fi, if I remember correctly. There's also LPWA implementations of the smart button itself that can be keyed for any individual application. So the smart button itself can also be retasked as something of like a lone person alarm, or in the health and assisted living use case there, a fall detector. So if an OAP living in sheltered housing, for instance, falls over and they're wearing one of these pendants, they can press the button, immediately it'll send an alarm, somebody will be dispatched to assist. Package pickup service, customer satisfaction monitoring. We've all seen at the airport or IKEA, after you clear security or if you clear IKEA itself, having picked up whatever flat pack furniture you're desiring for the weekend, there's always going to be a board that says, were you happy, were you sad, were you indifferent? That's one of those applications and being used in anger there. Agriculture, livestock management, we see that being used for cattle tracking. Cattle itself it's an extremely expensive asset, into the multi-thousands. Typically we'll see those assets being fitted with an intelligent collar. And we've seen them doing some really quite clever stuff. We're not just talking about showing you where the cow or the horse actually is. In some cases we've seen horse blankets that have been able to detect the temperature and the heart rate of the animal itself. So you can tell if the animal is under duress, if it's running too hot, if it's running too cold, you can bring it into livery, so on and so forth. So there's a huge breadth of instrumentation and data you can pull out. Really, your use cases are only limited by your imagination. Smart cities. Everybody's heard this huge push for smart cities, and a number of entities, including Bristol, are moving towards implementing this in anger. Cambridge in particular are pushing ahead in earnest with a number of technologies for smart cities, and are implementing some extremely effective trials. Again, going back to the asset management use case, dumpster monitoring is another big thing. You want to know if your bin is actually where it says it's going to be, or is it on fire? Is it at the bottom of the canal? Has somebody stolen it? Are they using it at their house? Air quality monitoring, fire hydrant monitoring, bit on the state side, that one. Street lighting management, water level monitoring. Again, all things that can generate either a flow of statistical or Boolean data that is normally quite hard to pull back to one location. Way back historically, even prior to GPRS, a lot of this monitoring would have been done on old dial-up circuits or E&M or even on GPRS in later days. Because of the volume of information that you're talking about, you want to reduce that cost and you want to be more effective as to how much of it you pull in. So with lower cost devices and a much, much simpler way of getting the information from A to B, you can really go all out and start throwing these sensors out onto as many assets as you want. It's, again, limited by your imagination. Health and assisted living is it's a great use case. We see a big uptake in that in the UK, and that's driven by one particular organisation who started out in New Zealand and Australia. What they've implemented there is an assisted living product that sounds inherently complex when you describe it on paper, but effectively it's just a PIR that tracks motion over a given period of time. Now, it's not intelligent enough to track this motion. All it's doing is reporting on PIR events, which are a number of bytes at a time. But over time, these build up a bigger picture of exactly what's going on in a room. So if you were to look at one instance of a PIR being triggered in here, for instance, it wouldn't be particularly interesting. If you were to build it up over time, correlated between 3 or 4 or 5 individual PIRs, and to aggregate that data together, you get a much clearer picture of exactly what's going on, almost like heat mapping the room. So the way that works is it determines what the normal behaviour is for somebody requiring assisted living, and it builds up a pattern over time of what their normal behaviour pattern looks like. So Doris might get up at 8 in the morning, she might make herself a cup of tea, she might sit and read the paper for an hour. She then might go through to the living room to listen to the wireless. Who knows? If she deviates from that pattern, if it's been assumed to be a normal one, then we can pretty safely assure ourselves that there's something wrong here, somebody needs to go and visit, so let's go and schedule a health visitor to make sure everything's ticking over as per normal. Finally, the home use cases, and I touched briefly on a couple of them there for leak detection and humidity detection. Sound detectors, a home alarm system, again going back to the PIR use case there. Smoke detectors, which we're seeing in abundance now. They can be deployed wirelessly throughout an MDU or a premise, and all come back to some single pane of glass interface, either on your cell phone or on a management and monitoring platform. USB dongle for set-top box, not a use case. I'm really not sure why that's in there, so we can strike that off. Again, not really my presentation. Water leak detection we've touched upon, and outdoor sports GPS tracker. There are a number of augmented GPS solutions out there. Typically they're worn as a bracelet or a neck or back and front assisted solution. Probably the best example of a GPS tracker is a lone worker in a security industry. So security is, by its very nature, always going to be quite risky. Risk management is the name of the game. In some countries where you're dealing with people who are a bit more desperate than your common criminal, you might come up against a firearm. In some cases, they might have the drop on you. How do you alert that you're being held at gunpoint? Well, there's a bracelet that if you hold it and shake your hand in a particular way without getting shot, oddly, then that sends an alarm to let you know, I'm being held against my will, I'm being held under duress. Please somebody dispatch another member of the security services to come and assist. And that's had a huge uptake in some of the Latin American regions. So the key point behind LPWA is that it's low cost and low power. We send very small messages with a much simpler overhead. So our requirement for radio resource control, power amplifiers, front ends, all that just goes away. It doesn't go away, it becomes a lot more simpler. So because of the smaller bandwidth and the lower MCSs, that means we can simplify fabrication. And because we're simplifying the network and we're using unlicensed frequencies, again, that reduces our cost. It becomes a much more attractive proposition for everybody. Typically, more than half of the IoT devices that I've touched upon in all the previous use cases would only need 12 bytes or less. It sounds like a bit of a reach. Believe me, the first time I saw the technology being implemented, I had my doubts. It works in earnest. So GPS coordinates will typically take up 6 bytes. If your device is equipped with a Wi-Fi sensor and it has the ability to pick up an SSID from the local Wi-Fi spectrum on 2, 4 or 5, then it can transmit that as 10 bytes, and then you can do a lookup on your back end against the Google data and any other database you may have to see what's local and use that to assist in correlation of GPS. Temperature and humidity and pressure, roughly 2 bytes. Speed reporting, a lot of the equipment that we see is fitted with an accelerometer for drop or transport purposes, 1 byte. And object status, largely Boolean, I'm okay, I'm not okay, 1 byte. So you can see there, we're not talking megabits to get information from A to B from all these devices in the field. Our typical bandwidth is around about 200 kilohertz, and our typical bit rate is around about 10 kilobits a second. Currently, as it stands, and I should maybe have gone into more detail, but I will in the later slides, on the not competing but complementary technologies that are at play here. So we have NB-IoT, which is the MNO-based offering, which is available tomorrow. It's very much a case of jam tomorrow with the MNOs. They'll tell you it's available and then shift the goalposts. it's still in development and testing. No doubt will find its way out to the field sometime soon. There's LoRa, which is the buy off the shelf solution, as it were, from Semtech, who are the semiconductor manufacturer. And there's the Sigfox, glaringly misspelt there, I might add, solution, which is what we ourselves, WND, deploy throughout UK and LATAM. Not to beat around the bush, but Sigfox is actually in quite wide dispersal across EMEA now, on an equal footing with LoRa. And again, this isn't a competition that we're engaged in, it's a complementary thing. And we'll see why shortly. So again, reiterating this old trope of imagination being the limit. Geolocation of pallets, dogs, cats, cows, trailers, refrigerators. Cat is a bit of a weird one. You might ask, what? How does that even work? I actually have a couple of cats myself and use this tracking solution, and it's for peace of mind more than anything else. You get to see where the animal is at any given point. Granted, they have to be within coverage, otherwise you're out of luck. But as we push on, coverage isn't really too much of an issue. And the same with the dog. These are family members that you want to look after. It becomes a similar application to a child proximity alarm. If you're out in public with your children and they wander off, you want to be immediately alerted. You can't be there all the time. It's nice to have that peace of mind. Again, going back to the trailer refrigerator, that's cold chain implementation. So we want to make sure that anything that's going on, there's no spoilage, the cold chain is maintained, everything's in working order when it gets to the far end. Coffee capsule used with the colour used in a coffee machine. I can honestly hold my hand up and blame Chris wholly for this one. I'm not entirely sure where that has come from. Litres of water gone through a filter. We see that in the smart metering applications. So we will have a number of metering applications that can be run either on a TikTok basis, whereby we get usage data through, or we can get a bulk aggregate upload of what the flow has been for the day. Leak detected in a building, again, that goes back to the use case that I mentioned there of it being fitted at build or retrofitted. Electricity, water and gas meter reading, again, eliminating the requirement for somebody to be going around with a clipboard and ticking off numbers. Temperature of a refrigerator, that's our cold chain use case there. Monitoring of an alarm, and there's a number of use cases you can implement there. Alarms are generally Boolean in their nature unless you've got multiple levels for them. Within 12 bytes, there's a whole load of information you can convey across there. And probably more interesting for the majority of people in this room, monitoring of broadband equipment. What we've seen and what's enabled us to deploy in anger in a lot of locations is to provide out-of-band instrumentation and environmental control for plant assets. Small enough that they'll fit in an Etsy cabinet, small enough that they'll sit next to a Flexi, small enough that they'll fit in a macro cabinet. That way, even if your battery plant is out of operation or is substandard for whatever reason, you don't have to worry about last gasp. You can still get instrumentation as to whether the cabinet has been opened or closed, what your battery levels are, what the temperature and humidity is. You've effectively got a second wayside channel to get management data back about your plant assets. So the three main solutions today, I briefly touched upon in the earlier slide. NB-IoT, which is the MNO sponsors or MNO specific offering. LoRa and LoRaWAN, which is the off-the-shelf solution. And the Sigfox implementation, which is what we ourselves roll out. Again, no one-size solution fits all. Everybody makes big of this in the industry press as to who's going to win out in the IoT war. There's no such thing. They're all complementary technologies. They all have their individual use cases. So the NB-IoT is designed for the lower power and data rates than the LTE-M standard, which was originally precept on the 3GPP IoT with up to 1 meg throughput, running at less than 250k, 100 byte payload average, and using some fairly chunky coding there with FDM and SCFDMA. Drops the performance and power to another level. It's not so much of a heavy hitter as the traditional GPRS or any of the over and above technologies beyond that. Still based on a cellular architecture. invariably, because it's just a line card upgrade in your RBS or your eNode B. Sub-channelized, listen before talk with handshaking, employs forward error correction, power control, identification, all the things that we take for granted with the traditional cellular networks, and of course is implemented with the HLR and VLR architecture, so we can implement full roaming across an estate of devices. So the basic SWOT analysis shows us that our strengths are, we're backed by the 3GPP, we're not going anywhere. License frequencies, great, we've got the ARRI at our back if we need them to be so. Hundreds of vendors, Huawei, Ericsson, Motorola, if they still exist in some way, shape or form, whoever else is manufacturing. Weaknesses, optimised for 100 messages a day, and you've got 14 frequency bands to deal with. Opportunities, again, you're MNO backed, but your threats are your ASIC costs, the royalties from the semiconductor manufacturers, and the power consumption of the device itself. LoRaWAN. You've probably seen LoRa devices on Amazon, or you've probably actually seen them on UTC assets in the field. They're in common deployment now. Designed to complement the LTE-M offering, less than 50 kilobits, chirp spread spectrum, so it looks pretty messy when it keys up on an SA. Unlicensed bands, so we can make use of 433, 868 and 915. But again, it's proprietary to Semtech, who are the chipset manufacturer. So there's a licensing model applied to any of the ASICs that they roll out. Strengths, it's a private network, inherently. If you can liken a LoRaWAN base station to an individual access point that you might buy off Amazon, in opposition to an NB-IoT offering or our offering, which would be a managed end-to-end solution. That's great in some ways, because if you are a defence or a state contractor, or you're operating a private utility network that has to be air-gapped, you can get away with it. You can implement this and still maintain IoT assets out in the field. Weaknesses, proprietary, single dual source ASIC, bit of a risk. Semtech aren't going anywhere in a hurry, but there is still that single point of failure. Opportunities, again, large customers who want a private network, i.e. utilities. Threats, high overlap with NB-IoT, and MNO partners may just drop you in favour of NB-IoT. Probably everybody here remembers the WiMAX and LTE crossover and how there was going to be a coexistence, and then Ericsson eventually just steamrollered everything and went, it's LTE. There is a risk of that happening here. It's a great technology, but it might just get flattened by the adoption from the MNOs. Ourselves, not to blow our own horn, designed for low power, low data rates. 600 BPS and lower. We use incredibly low coding schemes for this, BPSK in actuality. We're using a 12 byte payload max, and it's ultra narrowband with Aloha. Again, BPSK with no forward error correction. We don't care. We send the message 3 times in space and time, and it should be in an optimized network received by 3 base stations, so there is a huge element of redundancy there. It's proprietary to Sigfox, but there's no ASIC licensing fees, so anybody can make the chipset for the devices. There's a slew of existing sub-gig ASICs that are compatible with LoRa and NB-IoT, almost as a system on a chip, all in one for IoT. Still early days, but we're seeing more and more of these devices come to the fore. Again, our strengths, we've got loads of existing ASICs. It's a one-stop certification from the manufacturer, Sigfox. Our weaknesses are we've got a limited duty cycle. We listen for 95% of the time and transmit for 5. Because all of the instrumentation coming from the field is effectively a flood if you scale it out to millions of devices, there's no point in sending acknowledgement traffic or probing traffic. It should only ever be if and when the device requires it. So any and all downlinks are initiated by the device. We never, as a network, tell the device to initiate the downlink. It's always on a given criteria, threshold, or condition that the device does this. Opportunities, it's very, very simple to implement. It's deployed effectively as a service worldwide. Our threats, again, we're proprietary. Currently there's only one access point vendor for the time being. So the basic LPWA business model, less stolen goods, less underutilized assets, people, equipment, vehicles, anything you can put a cost against. If you can track it and reduce the amount of spend on it, then you're making money. It's a better way to reduce wastage. Again, going back to the cold chain and the food supply use case, it sells itself in many cases. Coca-Cola, as an example, are huge in this right now. The take-up for this, we've accelerated things slightly. The perceived value of any of the data that you pull back on this system, it has to go above and beyond how much you're going to spend to actually get the infrastructure out there to monitor it. It's pointless building a network and then assuming that people will just pay to use it, in our experience. There needs to be a tangible value there to what you're doing. So what a lot of people don't realise is that the value that the data that we're accruing as IoT operators is it's not actually visible right now. Which sounds like smoke and mirrors, I'll freely admit that. However, if you think about going back to the individual use case of the PIR sensors, one gives you an individual picture of what's going on at a given point. Scale it out to 5. All right, you can see what's going on in a room. Scale that out for a full building. That becomes a much more valuable piece of data. What do you then do with that? It's only once the data is collected and analysed that the value goes up. When people see the instrumentation that you could pull off, they become a lot more enlightened, as it were. Connectivity is a tiny part of the value proposition here. We are, as an operator, we're pushing these things out effectively for free. So our base stations are going out all over the country right now. We're rapidly approaching 75 to 80% coverage. For the devices themselves, typically it's less than 5 to 10% of the total cost for the implementation. I wish I actually had some devices here with me. Unfortunately, hindsight is great. It would have been good to show them around. Demand has already started to implement this as a service. Nobody's really interested in spending money hand over fist on implementing hardware, software and connectivity. They want it bundled up into a subscription. So you've got an immediate return on your investment. You just want to be able to buy a device, turn it up and start seeing data. And that's where an IoT operator pitches in. They're not going to charge you for implementing it, or as a previous incumbent used to do, charge around about 14k in roof rents just to have a base station and 70k a year to rent the base station itself. That's nonsensical. That just doesn't work. The examples, and then labouring the old point of the use cases there, metering. If you're a meter operator, you only want to see the data. You don't really care how the meter actually gets that in there. The data is what's actually interesting to you. You might purchase time on a contract. So as an example, if you're starting an energy campaign as a utility operator, you might pull the trigger on a campaign and go, we'll update these meters on a given basis over a given period of time, and we only want to see that information from that given period of time. You can do that. You don't have to be buying the data all the time. It can still be trickling in. You're only paying for the access to it and whatever you accrue over a given length of time. Cattle tracking. Way back in the mist of time, I used to work with a company that did a cattle tracking system, and it was a huge amount of expenditure to get this information from the point of birth right up to the plate. And this was mainly to prevent BSE and CJD from finding its way into the food chain. With this, the breeder will only pay for the use during the lifespan of the animal. Tracking, you might only be interested in the asset being tracked for a given period of time. You might only want to know, okay, well I've put my goods into that container, so I want to track that container and that one alone. I'm not interested in tracking all the containers that belong to that shipping firm. I only want to know where that one's going. It becomes as a service. So that appears to be an unwitting end to Mr. Battier's production.